Hello. Today we will be discussing 3D shapes. So we finally made it to the three-dimensional world. Unfortunately, I don't have my 3D shapes home with me to show you. If we were in class, I'd have all of these fun 3D shapes for you, but we got to do two-dimensional stuff. Alright, so the way this goes is we cover surface area and lateral area today. We cover volume the next class. So here we go. We have a 3D drawing. This is called a prism. Now there's a prism, and then a special type of prism. It's called a cylinder. It says a circle. And there's a pyramid, and a special type of pyramid is called a cone. And then there's the spheres. So you really 3D shape is either going to be a prism or a prism-esque shape, a pyramid, or a sphere. So here we go. This is called a right prism, and this is an oblique prism. The difference between a right and oblique is that the oblique is slanted a little bit, and you have to measure the height kind of off to the side a little bit. Height is always measured at a right angle. Now we can take a prism and unfold it like this. That's called a net. When you unfold it, it's called the net. This is what a cylinder looks like when you unfold it. You'd have one big rectangle and two circles. Alright, so as far as surface area goes, we can come up with a formula for the surface area. We're talking about area, and then lateral area is something else. Surface area is how many squares would fit on the entire surface of that shape. If I were to paint the shape, how much paint would I need? How much surface area would I cover? Alright, so we can come up with a formula for this, and it looks something like this. To find the surface area, you first need to just do two bases. Surface area. So you got two bases. Now I've used a big B here, and a big B means the area of the base. So we're doing the area of this base plus the area of this base. And then we just need to do the area of this big rectangle right here. Now this big rectangle has dimensions h times a plus b plus c. That's a plus b plus c. Now what does a, b, and c make? A, b, and c, when I put them together here like this whole length, that makes the perimeter of the base. Alright, so there's our formula. If you don't understand where the formula came from, that's okay, but for now we need to know how to plug into the formula and what all this means. So 2b plus HP, where b is the area of the base and p is the perimeter of the base. It's all about that base. In fact, there's a whole song about it. You might know it. The surface area of a right prism, two bases plus h times perimeter. Alright? And then the lateral area is just the part without the bases. It's just the parts going around the sides. It's not the top and the bottom. So how would that change the formula? The lateral area formula is just HP. Notice that there's not two bases. The surface area has two bases. Lateral area does not have the two bases. Now as far as the oblique prism goes, it's the exact same thing. Tilting the prism does not affect the surface area. You find the lateral areas plus the two bases. For a cylinder is a prism. So the surface area is the same thing, 2b plus HP. However, we can customize it because a cylinder always has a circle base. So instead of writing B for base, we can write pi r squared. And instead of writing P for perimeter, we can write 2 pi r. Alright, so I like to do 2 pi r squared plus 2 pi r h. Alright, sorry, little room. That's the way I like to write my surface area formula. But basically it's the same as this. It's 2b plus HP. We plugged in the area and we plugged in the circumference. The lateral area, therefore, would be equal to just this part. So it does not have your two bases. It just has your h times your p. It has your 2 pi r h. That's your lateral area formula. And guess what? It's the same for the oblique, and it's the same for the oblique. For a pyramid. Now a pyramid is different from a prism. A pyramid only has one base. So if we are finding the surface area, this is what a net looks like of a pyramid. It's got your base, and then it's got a bunch of triangles shooting off of it. Those are what the sides are of a pyramid. It's a bunch of triangles. So as far as the surface area goes, you got one base plus a bunch of triangles. You got one triangle per side. So you got, let's call it n triangles, n being the number of sides, and then a bunch of triangles. Notice that's a little b. That's the length of the base, whereas the big B is the area of the base. So don't forget that the little b means the length of the base of a triangle in this case. Alright, so we'll call it a big B. Alright. Now, what is the base of one of these triangles but the length of a side? And the height is something called slant height. Alright, that's a very, very important thing. This height of this triangle is the slant height. It's going down the side. That's called the slant height. It's not the height, it's the slant height. The height going down the side of the face. And now we can reorder this equation. 1/2 L, and if you take n times s, that's the perimeter of the base. Alright, so there is our formula. If you don't understand where that all just came from, it's okay. Surface area equals base plus 1/2 LP, where L is called the slant height. Look at this diagram. This is the altitude, which is also known as the height. And then this is the slant height. It's going down the side of the pyramid. Alright. The lateral area, therefore, just does not include this base. It's 1/2 LP. It would not include the base. For a non-regular pyramid, things start to get a little crazy because these triangles are now different. This triangle is different from this triangle, which is different from that side, which is different from that side. So for the surface area of a non-regular pyramid, you have to do each face individually. And same for that one as well. A cone is a custom pyramid with a circle base. This is what a cone looks like when you fold it out. It's got a little Pac-Man and imagine that coming together and going on top of there. Really wish I could do this in person. So we have a cone. Let's start with base plus 1/2 LP. Pi r squared for the base. And the perimeter is 2 pi r because it's circumference. These cancel off, which leaves us with pi r squared plus L pi r. There's our formula for the surface area. I'm going to write it. I'm going to write pi r squared plus pi r L. Has a little alliteration going on, and it helps. For the lateral area is just the curved part. Alright, so just this part does not include the base, so we are not going to include the pi r squared, so the lateral area would be equal to just pi r L. Alright. For a sphere, can't really explain this one to you without going into calculus a little bit. What we end up having to do is to take the sphere, draw its net, do infinite many pieces of this, and add them all up, and you end up getting the surface area of the following: 4 pi r squared. That's it. 4 pi r squared. The lateral area of a sphere, there's really no such thing, because a sphere is a sphere. It's all just one surface, so we just have like the surface area of a sphere. A hemisphere now is interesting because you take a half of a sphere, but then don't forget you got a bottom that you have to add, plus the bottom. Alright, so you got a half of a sphere. So if a whole sphere is 4 pi r squared, a half of a sphere is 2 pi r squared. And then the bottom circle is another pi r squared. So how many pi r squareds do we have? We have 3 pi r squareds. So for the surface area of a hemisphere is 3 pi r squared. And the lateral area, I guess that would just be this part, just the dome part. If we're looking for just the dome part, perhaps that would just be 2 pi r squared. Oh wow, those are all of our formulas for surface area and lateral area. That's a lot. But the good news is, you don't have to memorize any of these formulas. You will be given all of these formulas. But if you know how to get the formulas, you don't have to memorize them. If you know what's going on, I mean, I don't think I have them memorized. I just know how to get them. With that said, these are formulas. You can use this formula sheet on future tests and quizzes, and I'll provide the formulas as well. Big things on here. Big B is the area of the base, whereas little b is the length of the base. Big difference. P is the perimeter of the base. Perimeter of the base only. And the other big one is this L. It's the slant height. It's going down the side of the pyramid. Not the height, the slant height. The slant height is always going to be larger than the height, because it's like the hypotenuse of a right triangle. Alright, part 2 coming.